Let's now learn how to integrate powers of secant. These integrals look like this, where n is the power of secant, and n can be either even or odd. We're first going to look at the case when the power of secant is even. And we're going to look at the example, the integral of secant to the 4th x dx. I've written down steps that we can follow, and we'll work through these one by one as we walk through our example. Our first step is to pull off secant² x and group it with dx. We have the integral secant to the 4th x dx, and our first step is to pull off a secant², so we have a secant² x left, and then we have a secant² x that we pulled off, and our dx. The reason that we're doing this is we have an even power of secant left, and we can change that secant to tangent, and then the derivative of tangent is secant², which we have right there. This is exactly what step 2 tells us to do. In step 2, we're going to rewrite our secant² x that I have highlighted in blue, and we're going to rewrite it as 1 plus tangent² x. I wrote that up here on the right in this green box. And then we have our secant² x dx. Let's go ahead and let's make this into two integrals. Our first integral is secant² x dx. And then our second integral is tangent² x secant² x dx. This first integral we can go ahead and just write down because that's a formula that we know. The derivative of tangent is secant², so the integral of secant² is just tangent x. Plus, and then for the second one, we have to go back up here to the top and look at step 3. We are going to let u be equal to tangent x and then use u-substitution. Over here, let's write our step 3, and we're going to say u is equal to tangent x, du is equal to secant² x dx. Now our integral becomes the integral tangent² x, so this is u² times secant² x dx, which is du. We know this integrates to 1/3 u³. Our u is tangent, so this is 1/3 tangent cubed x. Now let's go ahead and let's combine our answers. So we have the integral secant to the 4th x dx is equal to tangent x plus 1/3 tangent cubed x, and then we add on our constant c. And there's our answer. The second case we're going to look at is when we're integrating an odd power of secant. The example that we're going to look at is secant³ x dx. I've written down steps that we can follow, and we'll walk through these one by one. Our first step is to pull off secant² x and group it with dx. Let's go ahead and let's do that. We have the integral secant³ x dx. And in our first step, we are going to pull off a secant² x and group it with dx. So that leaves us with 1 secant x, and then we have secant² x dx. The reason that we're doing this is a bit complicated, but let me walk you through this. To solve this problem, we are going to have to use integration by parts. Don't worry, I'll walk you through it. When we use integration by parts, we need a dv that we can integrate, and notice that we can integrate secant² x. It's just going to be tangent x. And that's exactly why we had to pull off a secant² x. Let's go back up here to the top and look at step 2. It says to integrate by parts using dv is secant² x dx. So we'll put a 2 down here. We are going to let u be equal to secant x, and then dv be equal to secant² squared x dx. Du is equal to secant x tangent x. And we can't forget our dx. And then v is the integral of secant squared, which is just tangent x. Up here on the right, I put down the formula for integration by parts in case you've forgotten it. And let's go ahead and let's apply that formula now. Our integral is equal to uv, so this is secant x tangent x, minus the integral v, which is tangent x, times du, which is secant x tangent x dx. Let's now focus on this integral on the right. Let's rewrite this because we can combine the tangents. So this is tangent squared x times secant x dx. Now we have to think about what to do. The derivative of secant is secant tangent, so that's not going to help. The derivative of tangent is secant squared, so that's not going to help. So let's see, what else could we do? We could change our tangent squared right here into secant squared. What would that give us? Let's see. If we changed it into secant squared, we would get a secant cubed, and then we could combine that with our original integral. So that's what we're going to do. We are going to make the substitution. Tangent squared is secant squared x minus 1, and we multiply that by secant x dx. So this becomes minus the integral secant cubed x, and then we have a minus and negative, so this is plus the integral secant x dx. Now let's go ahead and let's combine everything. I'm going to write down the integral secant cubed x dx is equal to our u times v, which was our secant x tangent x. And then we have minus the integral secant cubed x, and I just realized I forgot the dx there. And now we're going to add on the integral of secant x. We know what that is. It's a formula. It is the natural log of the absolute value of secant x plus tangent x. We're going to hold off on the plus c until we get done. We're going to take this integral and combine it with this one. So we have 2, the integral secant cubed x dx. And what we have left is our secant x tangent x plus our natural log absolute value secant x plus tangent x. This is why Calculus 2 is such a hard course. Now all we have to do is divide by 2. So we have secant cubed x dx is equal to 1/2 secant x tangent x plus 1/2 natural log absolute value secant x plus tangent x. Now we add on our plus c. And there's our answer. I know this was hard, but working through problems like this are really good because you are learning how to recognize patterns, decide what to do, and this develops problem-solving flexibility that you can use in all your future courses. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.